The majority of the time, the reason we're interested in looking in the infrared is because you get really specific information about what stuff is made of if you look at how it absorbs infrared light.
Amazing.
So everything is made of molecules, and those molecules will vibrate and twist around at some particular energy. And the energy that does that matches the infrared part of the spectrum. So if you shine infrared light at a particular molecule, it'll absorb that in a very specific way that tells you exactly what it is on a molecular level. And so there's a region of the infrared that often gets called the fingerprint region, because it serves as a fingerprint of identifying what it's made of. So obviously that's useful for a really wide range of things.
Yep.
We use it to identify plastics. It's very interesting for diagnostic medicine. You can identify, based on the molecular composition, DNA in a cell compared to other proteins, and this ends up being a really specific biomarker for things like solid cancers. The main thing is that it's a really specific source of information, and that's why it's so powerful, because you can apply that to pretty much anything, because everything has this signature. So a lot of the work is very much focused on the applications of this and pushing to whatever wavelengths you need to be able to do these different diagnostic techniques for whatever application it is. I'm going in two directions. One is a bit more of a fundamental approach. I want to see what we can do to improve the resolution.
Yeah.
So microscopy has had all of these big revolutions from super resolution techniques.
Yeah.
They come in all different shapes and forms, and I want to see what can I borrow and learn from classical microscopy and apply to these systems, so that then hopefully that can be used for things like the diagnostic medicine type of applications. So that's one side of it, a bit more exploratory, a bit more fundamental science. And the other side is that I really want to make these systems look like microscopes. And I think, well, the hope is that means it gets into the hands of people who would then use it and they know what to expect. I would much rather people used it because it was useful rather than because it's quantum. And so if I can put all of the quantum magic stuff into a black box that I hide inside of a microscope, and the person I give it to doesn't have to understand anything about it, they can just use it like the microscope they used to, I think that's the goal.